In this video, we are going to continue with the West African Examination Council, and we will be starting today with November 2011 Part B essay. This paper is 2 hours and it has a total of 100 marks. We are going to be concentrating on the West African Senior School Certificate Examination Chemistry Paper 2. Essay question 1 and 2. Before we continue, I want to thank those of you who have taken your time to subscribe to our channel. But for those of you who haven't subscribed to our channel, please like this video, share to other learners, and most importantly, take your time and subscribe to this channel so that other questions we are going to be discussing will be coming directly to you. My special gratitude goes to myschoolgist.com for making available to us the question paper. Thank you for taking your time to subscribe to our channel. Let's get started. We are starting with question number 1. Question number 1. Section 1. For all candidates, answer 3 questions from this section. Question number 1. A. What is a transition element? What is a transition element? It has 2 marks. What is a transition element? Okay, I've prepared some answers here for you. What is a transition element? Remember that not all D block elements are transition elements. Not all D block elements are transition elements. Therefore, we can define a transition element as a transition element is a D block element that forms one or more stable ions with an incomplete D subshell. It forms one or more stable ions with an incomplete D subshell. Question number 2. Question number 2. B part. Ion can be represented as the atomic number for ion is 26, and the formula for ion. 1. Roman 1. Write the electron configuration for ion. Electron configuration for ion. Ion 26. Atomic number is 26. Atomic number is equal to the number of electron. Atomic number is equal to proton number. We now say proton number is equal to the number of electrons. So we are going to use 26 as the number of electrons in writing our electron configuration. So the electron configuration for ion is, we write agon, that is B1, agon, 3d6, 4s2. Or if you want to make it complete, you can say 1s2, 2s2, 2p6, 3s2, 3p6. Then 3d6 and 4s2. From 1s2 to 3p6, that is the electron configuration of agon. Then we complete with 3d6 and 4s2. B2. Explain briefly why ion exhibits 1. Paramagnetism. 2. Variable oxidation a variable oxidation. Variable oxidation states, yeah. Explain why ion exhibits paramagnetism and variable oxidation. They are variable oxidation state. All these are altogether 10 marks. So you need to, the material you write will determine the number of marks. Okay, here, paramagnetism, B1, paramagnetism. All right. Ion exhibit paramagnetism because these are the reasons why ion exhibit paramagnetism. Because it contains unpaired electrons in the d orbital. If you look at it like what I wrote here, if you look at it like what I wrote here, in the it contains ion exhibit paramagnetism because it contains unpaired electrons in the d orbitals. I will show it to you. If you have time, you write and still write the electrons in orbitals to show the examiner. But if the time is not there, just write the points there. Everything will be okay. So it contains unpaired electrons in the d orbitals. The unpaired electrons in the d orbitals are responsible for the magnetic properties. The unpaired electrons are responsible for the magnetic properties. And finally, this magnetic character increases from left to right across the d block as the number of unpaired electrons they increase from 1 to 5. So, since you said they contain unpaired electrons in the d orbitals, and the unpaired electrons are responsible for the magnetic property, these are the two major points. Unpaired electrons in the d orbitals, and these unpaired electrons are responsible for the magnetic property. These are the major points. Then you can go ahead to write electrons or to draw electrons in orbitals. Like I said, this is the electron configuration for ion. The 4s orbital has 2 electrons. It is full. Then the 3d, the first orbital is full because 3d, after this, we have to fill this. There are 6 electrons here. According to the Hund principle, you have to fill electrons singly. 1, 2, 3, 4, 5. Before, when you complete filling them singly, before you can now start pairing them. So, since there are 6 electrons, there are altogether 6 electrons in the d orbitals. In the d orbital, we have filled 5, and 1 is left. This is the only one that is full. So the rest are unpaired. And these are the unpaired electrons that are responsible for the magnetic property of ion. That is just all. If you can write this and write the first major points, then you have all your marks. Then, variable ion exhibit variable oxidation. That is variable oxidation state. How? Ion exhibit variable oxidation state because the first point, it has available electrons in the 4s and the 3d orbital for bonding. It has available electrons in the 4s and the 3d orbitals for bonding. That is for bonding. Then 2, the number of electrons available for bonding, since it is a metal, it needs to, the electrons are going to be lost. They are going to be lost. So the number of electrons available for bonding or to be lost in the 4s and in the 3d orbitals will determine the oxidation state of the ion. And lastly, when ion lose up to 3 electrons from the 4s and the 3d orbital, to form bonds with another atom, we say ion has 3 variable oxidation states. If we lose up to 3, we say it has 3 variable. If he loses 2, we say it has 2 variable. So now to show how it happens using electrons in boxes, this is how the whole thing goes. You need to write first the electron configuration of ion, then and write it in boxes. The 3D and the 4s, because we said the number of electrons available for bonding that is to be lost in the 4s and the 3D orbital determine the oxidation states of ion. So now we concentrate on the 4s and the 3D. Now in the 3D, as we said, the first orbital has full electron. After filling the 4s, we now come to 3D. Now, the first orbital in the 3D is full. We have only 3. We have 1, 2, 3, 4. We have 4 available electrons. Now, we said when the ion lose up to 3 electrons from the 4s and the 3D to form bonds with another atom, we say the ion has 3 variable oxidation states. In this case, we want to start with ion 2. Now, with ion 2, this is what happens. The first 2 electrons in the s orbital are lost. When the first 2 electrons are lost, it gives ion 2 plus. Now, again, that's why we say 4s0. It's only 3D that is left. Argon and the 3D, because there's nothing in the 4s orbital. Now, we have to target the 4s now. In taking electrons away, and the 3D now, in taking away electrons from the 3D now, what happened? We will have to start with the first orbital. We unpair it by removing, losing the ion 2 does what? 1 electron here is lost. From the paired electron, 1 is lost. And when 1 is lost, what happens? The oxidation number of ion 2 increases. And it now becomes what? Ion 3. So it now are unpaired. This is how you can write precisely and show the examiner. When you write like this and show to the examiner, okay, the examiner will have confidence that this student knows what he or she is writing. Okay, let's go. Let's proceed to the next question. Let's proceed to the next question. The next question is after variable oxidation state. The next question is B3. Mention 2 byproducts. Mention 2 byproducts in the extraction of iron in the blast furnace. 2 byproducts in the extraction of iron. Then question number 4. Write an equation to illustrate the formation of each of the byproduct in iron. There are 2 byproducts that we have to mention. So we have to write an equation. We have to write 2 equations here to illustrate how these byproducts are formed. Let's go there. Okay. The byproducts. What are the 2 byproducts in the formation of in the extraction of iron in the blast furnace? The byproducts, those byproducts, after iron has been extracted, what other products are being produced? The byproducts are what? We have 1, calcium silicate. Calcium silicate, that is what we call the slag. That is what we call the slag. The molten slag that is removed at the bottom of the the blast furnace. That slag is the one that we use we use in tarring our roads. The black component that we use in tarring our roads after iron has been extracted. Another component, another byproduct is carbon dioxide. Now, how are these formed? We need to write two equations how slag is being formed and carbon dioxide is being formed. One, the first one is slag, the formation of slag. In the extraction of iron, there are impurities in the iron, there are impurities found in the iron 3 oxide. Some of the impurities are silicon dioxide. These impurities that are found in iron, the only way to remove it is we will decompose calcium carbonate. When we decompose calcium carbonate, we will have calcium oxide and carbon dioxide. The calcium oxide that comes out from calcium carbonate will now react with the slag, and will now react with the silicon dioxide to form the slag. So this is the first equation: calcium oxide plus silicon dioxide to form the calcium silicate. This is the removal of the impurities. These are the impurities, and this is the final product, which is the slag that is being removed. Secondly, when carbon monoxide reacts with iron in the blast furnace, molten iron is being formed. Molten iron is being formed that runs right to the bottom, and the carbon dioxide is given off. Carbon dioxide is being given off. So this is the hematite, the ore from which iron is extracted. So this is the equation to give you carbon dioxide. This is the equation to give you the silicate, the calcium silicate, which we mentioned. Now, let's go to the next question. The last section of the question, not the last section. It is C. It is stated. C reads: list the elements present in each of the following alloys. We have steel, the steel alloy. Steel is an alloy. Bronze is an alloy. Brass is an alloy. And the soft solder is an alloy. Which are these elements that make up this alloy? These alloys, which are the elements or which are the components that are there? So let's go to C. The elements present in the various alloys are as follows. Now, when we have steel, the steel you have from the market, the steel you use for your cutlery and other things like that, or for rods that we use for our buildings, that one can only be obtained when there are a mixture of two or more elements. So the steel here, the steel alloy, the alloy contains iron and carbon. Some steel may also contain manganese and nickel. Some may contain iron and carbon. Then bronze. The alloy contains copper and tin. Then brass. The alloy contains copper and zinc. And finally, soft solder. The alloy contains what? The alloy contains tin and lead. Now let's go to the D part of it. The D part of it says, outline how a pure dry sample of silver chloride. Outline. You don't need to write detailedly. If I have written detailedly here, it is because I want you to understand. But outline is briefly, in a point form. You put a point and you give a point. You put a point and you state it. You put a point and you state it. You put a point and you state it. That is how outline is supposed to be presented. Outline is not essay. So outline how a pure dry sample of silver chloride could be obtained. Silver chloride could be obtained from aqueous solution of sodium chloride and silver trioxonitrate. Sodium chloride and silver trioxonitrate, that is silver nitrate. How can you obtain pure sample of silver chloride from this mixture? These are two salts. Chloride salt and the nitrate salt. How can you obtain a pure sample, a pure dry sample from this? When two salts are mixed together, the only way you can obtain a sample of the other one, a dry sample of the other one, is if there is a precipitate that is being formed. If there is a precipitate that is being formed, then there's a likelihood that you can obtain some pure dry sample of the other one. Let's see how you can do it. Okay, the D part of it, two salts. The first thing is, that's why I say you don't need to go into details, requirement you need to write the glass rod, you need to write beaker, no, you don't need to. You have been told outline. Don't go into experimental procedures. No, just outline a few of the main steps in doing it. So the first thing is mixing. Mixing is a point. You can just make a point that then mixing. That's just all. This is a point. This is a point here. You can say, let me just put it like this. Mixing, filtration, wash, precipitate, and crystallize. These are the points. Mixing, colon, aqueous solutions of sodium chloride and silver nitrate are mixed together in a beaker to obtain precipitate of insoluble silver chloride salt. Finish. You can write the equation. When the two salts are being mixed, silver chloride precipitate are formed. Point number 2, filtration. Use a filter paper and a funnel to filter off the silver chloride precipitate. Full stop. Point number 3, wash precipitate. Wash the filtered precipitate with distilled or deionized water. Point number 4, crystallization. The insoluble washed precipitate is scraped off the filter paper into a dish and dried in an oven or warm place to obtain what? To obtain a pure sample of silver chloride. That's just all. That's why we say outline. Make the point, you list what is supposed to happen. In this case, a precipitate is being formed. As the precipitate is being formed, you know some of the precipitate are on the filter paper. You have to scrape everything into what? Into the you have to scrape everything into a dish, evaporating dish. And then after everything, you put it in you don't crystallize it, and you put everything under there in the oven, and you have your you have the dry sample of it. So this is simple way you can do it. Don't go writing essay, please. Okay. Let's go to the E part. The E part of, I think that should be the last section of our question. Question number 1. The E part, if 2.4 gram of carbon, 2.4 gram of carbon is burnt completely in air, that's complete combustion. Complete combustion. If 2.4 gram of carbon is burnt completely in air, calculate the volume of carbon 4 oxide. Carbon 4 is carbon dioxide. Please, once more, there's something I want you to know. When I say carbon 4, please, there's something. When I say carbon 4, this is carbon 4. This is carbon dioxide. We say carbon 4 because we name them based on the oxidation number. Okay, according to the rule of naming, according to the rule of assigning oxidation number, oxygen has an oxidation number of -2. Oxygen has an oxidation number of -2. So 2 times -2 is -4. In that case, carbon is X. Let's say X minus 4. According to the rule, the sum total of the oxidation states here of the neutral compound is equal to 0. Equals to 0. Then X, which is carbon, X will equal to what? On this other side, +4. So carbon has an oxidation number of what? +4. That's why they say carbon 4 oxide. Carbon 4 oxide. Because carbon has an oxidation number of +4. Thank you. So let's get back to our calculation. Let's get back to our calculation. Okay, carbon is burnt, completely burnt. And the product is carbon 4. This is carbon dioxide. Now, calculate the volume of carbon dioxide that is being produced. Remember the value, the figures that you were given. You were given some figures there. You were told carbon has 12. The relative atomic mass of carbon is 12. The molar volume at standard temperature and pressure for a gas, the molar volume of a gas is what? Is 22.4 dm³ per mole. That's great. Okay, let's complete our calculation. Now, look at this very well. Look at this very well. Now, the first thing is write a balanced equation for the combustion of carbon. This is an equation for the combustion of carbon. That equation alone gives you 1 mark. Even though you have been told carbon 4, you have been given everything, but the examiner will want you to use that equation, because that equation again is going to guide you in your calculation. This is stoichiometry. So after writing the equation, carbon plus oxygen to give carbon dioxide, now you can use the equation now. If 1 mole, this is 1 mole of carbon here. If 1 mole of carbon produces 1 mole of carbon dioxide, because there is 1 mole here and there's 1 mole here. If 1 mole of carbon produces 1 mole of carbon dioxide. Therefore, we said how many moles were burnt? We said 22.4 grams of carbon were burnt. To know the number of moles of carbon that were burnt, since mole is given mass divided by the relative atomic mass, it is 2.4. 2.4 divided by 12. 12 is for carbon. 2.4 divided by 12 will give us 0.2. So since we are using moles in our calculation, we say if 1 mole of carbon produces 1 mole of carbon dioxide, then 0.2 mole of the carbon that was burnt, that is 2.4 divided by 12 of carbon that was burnt, will produce X carbon dioxide. We don't know X. We don't know X. Therefore, simple proportion, our value of X will be what? Our value is 2 times 1 divided by 1. So our value, the same value or that will be produced by this 0.2 mole is 0.2 moles of carbon dioxide that will be produced. We are told the molar volume of a gas, that's 1 mole of a gas contains what? 1 mole of a gas will occupy 22.4 dm cube, 1 mole. But how many moles is oxygen here? There are 0.2 moles. So the volume of, how many moles of is carbon dioxide here? Is 0.2 moles. So the volume of carbon dioxide produced by what? It is 0.2 moles of carbon dioxide times the 22.4. That will give us the total volume of carbon dioxide that is being occupied. And we'll have what? We'll have 4.48 dm cube. That will be the volume. That will be the volume of carbon dioxide that will be produced. That will be the volume of carbon dioxide that will be produced. So that is how you can do that. Thank you. Now let's go to question number 2. Let's go to question number 2. Question number 2. Before we continue, for those of you who haven't subscribed to our channel, please like this video, share to other learners who will be writing exam this coming examination season, and most importantly, take some time and subscribe to our channel. We are here to assist you in your exam. So should in case you have any problem in solving any problem during your studies, we are available at any time to assist you. Thank you. Question number 2. A. Consider the following list of elements: nitrogen, fluorine, aluminum, and potassium. Nitrogen, fluorine, aluminum, and potassium. Which of the elements, 1, forms diatomic molecule? The diatomic molecule with a triple bond. A triple bond. The one that will form a diatomic with a triple bond is nitrogen. 2 is nitrogen. 2 is the most reactive electropositive element. The most reactive electropositive element from nitrogen, fluorine, aluminum, and potassium. The answer is potassium. 3 forms amphoteric oxide. The only element that can form amphoteric oxide is a group 3 element in this group, which is aluminum. And 4 is the most reactive nonmetal. Halogens are the most reactive nonmetals. And the only halogen here is fluorine. So that is how you can get the answers. That is how you can get those answers. So if you have it, then it's okay. So that is it. I said the one with the triple bond is nitrogen for question number 2. The one that is the most reactive metal is potassium. I said for aluminum, for the other one that form amphoteric oxides is aluminum. The one that is the most reactive nonmetal is fluorine. We go to the B part. 2B. 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 State. B1. State what would be observed. State what would be observed if chlorine gas is passed into an aqueous solution of iron 2 chloride. Aqueous solution of iron 2 chloride. If chlorine gas is passed into a solution of aqueous 2 chloride, what would you observe? Then again, state what will be observed if chlorine gas is passed into an aqueous solution of potassium bromide. Okay, iron 2 chloride. See what will be observed. In iron 2 chloride, what will be observed is this. What will be observed when chlorine gas is passed aqueous solution of iron 2 chloride? So what will be observed will be what? The color, there's a color change. The color changes from the color will change. The color changes from orange to brown black when chlorine gas is passed into an aqueous solution of iron 2 chloride. The color will change from what? The color will change, or the color changes from orange to brown black. Then again, what will you observe when the chlorine gas is passed into an aqueous solution of potassium bromide? Potassium bromide. When iron 2 aqueous solution of iron 2 when chlorine is passed into an aqueous solution of potassium bromide, what will happen? The color of the solution turns orange. The color of the solution turns orange. Okay, let's go back again. Here, potassium bromide, I said the color will turn orange. Then they say give the name of the products. The name of the product when an aqueous solution of when chlorine is passed into an aqueous solution of iron 2 chloride. When chlorine is passed into an aqueous solution of iron 2 chloride, what would be the product? The product from here. Now, another one again. What will be the product? Give the name of the product that will be formed when chlorine gas is passed into an aqueous solution of potassium bromide into an iron 2 chloride and into potassium bromide. Okay, see what is going to happen here when chlorine gas is passed into this. When chlorine gas is passed into the first case, in the first case, when it is aqueous solution of iron 2 chloride, what will happen? Iron 2 chloride, what will happen there will be, it will be iron 3 chloride that will be formed. A solution of aqueous 2 iron 2 chloride. Iron 2 chloride plus chlorine will give us iron 3 chloride. So the product will be what? Iron 3 chloride that will be formed. The product is iron 3 chloride that will be formed. Then again, when chlorine is passed into an aqueous solution of what? Aqueous solution of potassium bromide. Chlorine plus potassium bromide. Remember that chlorine is above bromine at the group 7. Under group 7, under the halogens, chlorine is above bromine. So what will happen is that chlorine is going to displace bromine. Chlorine is going to displace bromine. Chlorine is more reactive than bromine. Chlorine is up in the reactivity series, or chlorine is up in the group more than bromine. Bromine is down. So for that reason, the halogen up is going to displace the one below. So chlorine is going to displace bromine. In that case, we'll have potassium chloride. In that case, we are going to have potassium chloride. Okay, let me show you how some of how the equations, the equation is part of it that we are going to write. We are coming to the equation. Now they now ask us 3, write an ionic equation. Write an ionic equation to represent how the ion 3 is formed and how the potassium chloride is being formed. The products here, they are telling us that the product that we have written here, write an ionic equation to show how this product is being formed and how this other product is being formed. So let's go to the ionic product. That is B3. Ionic product of this. Ionic product of this, B3. Okay. Remember, remember I have told you the product here is ion 3 chloride. Ionic, to write an ionic equation for ion 3 chloride, this is the equation. Ion 2 aqueous plus the chlorine gas will give you ion 3 plus this. Let me show you how to write the ionic equation. You may not know how we have come to this. This is how you can write it. I told you this is how it goes. This is in solution. This is ion 2 in solution. This is the ion 2 in solution. This is how it is in solution. This is how the ion 2 is in solution. The ion 2 in solution, this is how it is. So, oxidation, they told us ion 2 chloride. That is the first stage, the ion 2 chloride. Okay, now, in solution is going to give us ion 2 plus the chloride. So, let me show how the oxidation takes place and the reduction takes place before we have a full redox ionic equation. Oxidation, the ion 2 is oxidized to ion 3. It's going to lose an electron to have this. Now, reduction, the chlorine gas that's going to react with this, with it. The chlorine gas, what happened with the chlorine gas? The chlorine gas is going to gain electron. These electrons are lost by ion 2 to be ion 3. Then the electrons are now gained by the chlorine gas to form the chloride. We cancel out our ions. Our electrons, sorry. Now, everything is balanced. 2 here, ion, 2 chlorine here, and 2 chloride ion here. Now we can now add all the oxidation and reduction. Our redox equation will be 2 ion 2 plus chlorine gas to give us ion 3 to this. This is what we call chlorine plus this give us ion 3 chloride. This is how we got our ionic equation for this. That's how we got our ionic equation for this. Then secondly, for the second equation was chlorine is passed into an aqueous solution of potassium bromide. Now, potassium bromide. When potassium bromide, see potassium bromide, this is how it is. This is potassium bromide with chlorine. Chlorine is more reactive than bromine, so it's going to displace this to form potassium chloride, and bromine is displaced. Writing in an ionic form, writing this in an ionic form, what we are going to get from here what we are going to get from here, or when potassium bromide decomposes, when this breaks down, it's going to give us a positive potassium positive and a bromide positive. So it is the bromide positive that is going to react with the chloride. So the chlorine gas does what? Will react with the bromide. In this bromide, that is what we call potassium bromide. When this, because in aqueous solution, this is going to break down, it's going to be ionic, it's going to ionize. It will be bromide and it will be potassium iodide. It will be bromide and it will be potassium ion. So it is the bromide that is reacting. So because chlorine is more reactive, it's going to displace this one. And now it will be, bromide will be formed. I mean, a chloride ion will be formed and displacing this to be what we call bromine liquid that is be formed. So that's why I say this is how it is. This is the one, but this is not ionic. This is the ionic form of it. So let's go to question number B4. B4. What is B4 telling us? B4 is telling us, B4 says, suggest the type of reaction in each of 2B1 and 2B2. 2B1 and 2B2. The type of reaction in this, there were two ionic equations, the one with potassium bromide and the other one with ion 2 chloride. So what are these equations? Let's go back to our equation. You will know the type of equation, the type of reaction it is. So here, this one, the first reaction, this reaction here is a redox reaction. It's a redox reaction. Ion 2 chloride plus the chlorine gas. It's a redox reaction. This is a redox reaction because there was oxidation and the reduction. This one is being oxidized to plus. Look at this. From plus 2 to plus 3, that is oxidation. Then chlorine is 0. From 0 to -1, that's reduction. So this is a redox reaction. 1 is a redox reaction. Let's go here 2 again. This one is 0. Is 0. The oxidation state is 0. Then here is minus. This is reduction. Here, this is minus and this is 0. This is oxidation. Here, it is still oxidation. But the thing is this. They are all redox reaction. Redox, that is oxidation and reduction, meaning that they are all redox reaction. All of them are redox reaction. But in this case of 2, I said chlorine has displaced this person. Chlorine is going to displace bromine. So in that case, it is redox reaction, or you can put it here, or displacement reaction. Displacement reaction. You can equally write it that it is redox reaction for the one involving potassium bromide, or displacement reaction. The one above will displace the one below. Okay. 2C. 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 State two differences between conductors and electrolytes. Conductors and electrolytes. Okay. You have been hearing of conductor. You have been hearing of electrolyte in electrolysis. Okay. What are conductors and what are electrolytes? It should be remembered that conductors, electrolytes are salts. Mostly electrolytes are salt solutions because they are all full of ions. They are salt solutions, usually in ionic state. Electrolytes are salt solutions, usually in ionic state. However, in giving just two differences between electrolyte and two differences between electrolyte and conductor, we can say the first difference is an electrolyte carries electricity by the ions, that is the positive and the negative, which are freely moving. The ions, that is, I am saying that the ions in electrolyte are freely moving within the salt solution. So the electrolyte will carry electricity by the ions, which are freely moving within the salt solution. But for conductors, a conductor carries electricity by electrons moving through it, hopping from one atom to another. Once more, a conductor carries electricity by electrons moving through it, hopping from one atom to another. Meanwhile, an electrolyte carries electricity by ions which are freely moving within the salt solution. That's the first difference. The other one is by ions and the other one is by electrons. Okay, another difference. In an electrolyte, ionized atoms or molecules move to conduct electricity. I said in an electrolyte, ionized atoms or molecules move to conduct electricity. But in a conductor, electrons move to conduct electricity. It's just rotating between electrons and ions, ions. So let's go to the D part of the question, which is the last part of the question. The D part of the question. Consider the reaction represented by the following chemical equation. We have ammonia plus sulfuric acid plus aqueous, or we can say dilute sulfuric acid to form ammonium sulfate. Ammonia plus sulfuric acid to form ammonium sulfate. Determine the mass of ammonium tetraoxosulfate 6. That is the ammonium sulfate they are talking of. Determine the mass of ammonium tetraoxosulfate 6 that will be produced from 85 grams of ammonia. I told you, as this equation is like this, it is very, very important in stoichiometry. You have to use the number of moles of the reactants and the product. So determine the mass of this that is being produced from 85 grams of ammonia. Let's go to our solution page. Okay, on our solution page, you will see that on our solution page, you have to write the equation very well. Just the equation has been given to us very well. Ammonia plus sulfuric acid to give us, plus dilute sulfuric acid to give us ammonium sulfate. Calculate the amount of this that is produced by 85 grams of ammonia. The same thing I did in the other question. So the first step is look at the number of moles. 2 moles of ammonia are here, producing just 1 mole here. So we can now say if 2 moles of ammonia, that is here, can give 1 mole of ammonium sulfate, then 85 gram of ammonia is what? Ammonia has a molar mass of, this is ammonia. Nitrogen is 14 plus 1 times 3. 1 times 3. Yeah, 1 times 3 is 3. 3 plus 14 is 17. Ammonia has a molecular mass of 17. Ammonia has a molecular mass of 17. So in order to have the number of moles of ammonia, we will divide the mass that have been given by the molar mass of ammonia. So we were told to calculate the mass of ammonium sulfate that will be produced by the 85 gram. So 85 gram is what? 85 divided by 17 gram per mole of ammonia will give us 5 moles. Let's get back to our equation again. We said if 2 moles of ammonia can give 1 mole of ammonium sulfate, then 5 moles of ammonia, which we have just got from there, 5 moles of ammonia is equivalent to 85 gram of ammonia. 5 moles of ammonia. Since we are dealing with moles, convert everything into moles, please. 5 moles of ammonia will give X moles of ammonium sulfate. Our value of X will be what? Will be 5 times 1 divided by 2. 5 times 1 divided by 2 will have 2.5 moles of ammonium sulfate. We have got the number of moles of ammonium sulfate. To have the mass, the formula for mass is what? Moles times the formula mass or the molar mass. The formula mass or the molar mass, depending the compound. So the mass of ammonium sulfate will be the number of moles of the ammonium sulfate times its formula mass. And the formula mass for ammonium sulfate is what? The formula mass of ammonium sulfate is 132. We were given there that the molar mass is 132. If we can still remember, the molar mass of ammonia. The molar mass of ammonia is the formula mass of this is 132. We have calculated it. We have calculated everything. You can say 14. You can say it is 14 molar mass of this. We say nitrogen is 14 plus 4 hydrogen plus 4. That is 18. 18 times 2 times 2. Yeah, that is 36. Then sulfur is what? Sulfur is 32 plus sulfur plus 32. We have 68. Then oxygen is 16. 16 times 4, because there are 4 atoms of oxygen, that is 64. So 68 plus 64 plus 64. 132. We have 132. So 132, that is the molar mass of ammonium sulfate. The molar mass of ammonium sulfate. So now the 2.5 moles of ammonium sulfate that we got times the molar mass, which is 132, will give us what? Will give us 330 grams of ammonium sulfate that is being produced. So that is all we have. So thank you for listening. Once more, fellow learners, for you to always have the papers that we are solving, please take some time and subscribe to our channel. Try to share to other learners, and most importantly, to like this video. Thank you for listening. Wishing you best of luck.